Now we're going to look at solving rational equations. Our first step is just like when we're adding and subtracting, which is to factor the denominator if it's not already factored and simplified. Then we're going to get a common denominator, just like when we add subtract. The next step is what's different from adding and subtracting, which is where we're going to simplify and solve the numerators. Once I have the common denominator, I can focus on the numerators only. The last thing is we want to check that we don't have an excluded value, which is what would make my original denominator equal to 0. So for instance, if I had 1 over x minus 3 equals x over x minus 3, if I had an x value of 3, that would make my original denominator 0, so I can't have that solution if I got that when I solved the equation. So looking at this situation, I know y'all are used to cross multiplying, but we're going to see why does cross multiplying actually work, and it only works in this one situation, so we're going to broaden our idea of how to solve these equations. So put parentheses around your denominator. They don't have a GCF or anything that I can take out. So what I see is that this first one has a 6x plus 7, but the right side doesn't, so I'm going to multiply by 6x plus 7 over 6x plus 7. Remember, that's just a fancy 1. Then I have 2x plus 9 on the right side, so I need to multiply by 2x plus 9 over here. The key thing for when I'm solving is once I have this common denominator, I can focus just on these numerators. I don't need the denominators anymore because if the bottoms are equal, then I know that the tops need to be equal. So writing that out, I have 10 times 2x plus 9 equals 6 times 6x plus 7. And now we have an equation kind of like you would have had in an Algebra 1 class that we're just going to solve. 20x plus 90 equals 36x plus 42. Subtract your 20x. Y'all are in Algebra 2, so I'm sure at this point you can probably do this in your head, which is totally fine. 40, 50, 48 equals 16. So x equals 3. And then we want to check, our last step is to see if that would make my original denominator 0. Would that make my original denominator 0? No. Okay, so that's my answer. You can just visually check, is it going to make it 0 in the bottom? Okay, now we have one with monomials in the bottom. So I notice that I have a 2 and it's not written as a fraction, so we're going to put that over 1. So I'm going to go through and look for 2. Do all my denominators have a factor of 2 in the bottom? No. So this fraction I need to multiply by 2 over 2. This one I need to multiply by 2 over 2. Do they all have an x? Yes, yes, no. Now do they all have a 3? No. And I'm going to make that a times. Alright, now I'm going to have a common denominator. Once you have your common denominator, you're going to just solve the numerators. So 3 times 3 is 9, minus 5 times 2 is 10, equals 2 times 2 is 4, times 3 is 12, so 12x, and we simplify. Negative 1 equals 12x. Divide both sides by 12. So x equals negative 1 over 12. That is not going to make my denominator 0. What would have made my denominator 0 at the top is just 0. Here we want to be careful. Put parentheses around your denominator. There's nothing I can do to factor, and that's just going to prohibit me from somehow magically making that a plus 2. We don't want to do that. Once again, I have just a number, so I'm going to put that over 1. Now I'm going to see, do they all have a factor of x? This one does not, so we're going to multiply by x over x, and the right side does not. Then do they all have a factor of x plus 2? No. I know y'all don't have enough room on your notes to kind of squeeze these in. You'll probably have to just rewrite the problem, and I'm sorry about that. X plus 2 over x plus 2. Alright. And now once I have the common denominator, I focus on the numerator. So 5 times x plus 2 plus x times 9x minus 7 equals 9x times x plus 2. So 5x plus 10 plus 9x squared minus 7x equals 9x squared plus 18x. So the first thing I need to do is get the squared terms to be on the same side, but when I do that, what's going to happen? My squared terms are really going to go away. Yay! You're happy with that because otherwise we have to factor a quadratic formula. So I have 5x minus 7x would give me negative 2x plus 10 equals 18x. Add the 2x to both sides. Divide by 20. So I get x equals 1/2. Would 1/2 make my denominator equal to 0? No. So there's my solution. Alright, we get a little bit of a longer problem, but we treat it exactly the same way. Put parentheses around your denominators. If they don't have any squared terms or GCFs, put your 3 over 1. And now we go through, do they all have an x? Nope. Do they all have an x plus 2? Nope. On a test, I'm going to give you plenty of room so you can just write right on top of the problem like I'm doing right here. Still didn't leave enough room right there. Woo, that's a great parentheses. Alright, so let's double check. X plus 2, x plus 2, x plus 2, and we're good. So let's write our numerator. 3 times x plus 2 plus 4x equals 3x times x plus 2 minus 1 times x plus 2. I really suggest taking the time to write that line and not doing it all in your head, because when we get subtraction, we start making little mistakes. I'm just distributing all this stuff. Alright, now I have a whole bunch of stuff. I noticed that I have x squared in this problem, and when I have x squared in the problem, you need to get all of the terms on the same side. So since my x squared is positive, I'm going to move everything on the left. So first let me combine this. This would be 7x plus 6 equals 3x squared plus, let's simplify that as well, 5x minus 2. So I'm going to minus 7x and minus 6. Okay, now I need you to listen carefully. There are two ways to proceed here. You can factor, or you can just do quadratic formula. A lot of you are really fast at quadratic formula, so I might just suggest that. It does factor, and when I give you these problems, they are always going to factor. But since there is a 3 in front of my x squared, I cannot just use my shortcut. I would have to use x box and not just the x. So use it at your own peril. It's totally up to you. I'm going to do quadratic formula in the video because I think that is what will lead you most to success. So x equals opposite b plus or minus square root b squared minus 4 a c all over 2a. Excuse me. So 2 plus or minus 4 plus 96 is going to be 100 over 6. So once again, these should always factor, which means you should always be getting a perfect square there. So 2 plus or minus 10 over 6. 2 plus 10 is 12 over 6, which is 2. 2 minus 10 is negative 8 over 6, which is negative 4/3. So my two solutions are 2 and negative 4/3, but I need to not forget my last step, which is to just make sure they don't make my original denominator 0. Nope, we're good. Alright, this is a situation where I don't want to cross multiply, even though hypothetically cross multiplying would work. The reason is I'm going to get, if I cross multiply, a cubic, and I would have to multiply with the box, and it's going to make me hate my life, so don't do that. Start with your normal way, which is to factor any denominators. So this denominator is the first one we're having to really factor. What multiplies to 3 and adds to negative 4? There's only one thing that multiplies to 3. 3 and 1, and they're both going to be negative. X minus 3, x minus 1. They both have x minus 3, but they don't both have x minus 1. So I'm going to multiply by x minus 1, x minus 1. These are like the adding, subtracting problems that we did last class, where I need to multiply that using the box. Which in no way, shape, or form did I draw big enough right here. 3x squared, x, negative 3x, negative 1. So that numerator is 3x squared minus 2x minus 1 equals 6x plus 2. Now, unlike the other problem, my x squared is on the left side, and I'm going to leave it over there because it's positive. Hypothetically, you can do it if it's negative. My life suggestion to you is to keep it positive. Alright, negative 2x minus 6x, and then we're going to minus the 2. Once again, the problems I give you are always going to factor, but if it's a number in front of your or a number as your leading coefficient except for 1, I don't really suggest it. Copying all that down. So I would suggest doing quadratic formula. X equals opposite b plus or minus square root b squared minus 4ac all over 2a. So that gives me 8 plus or minus, we have 64 plus 12 times 3, 36. So 100 again, all over 6. So 8 plus or minus 10 over 6. So I get 18 over 6 and negative 2 over 6. So that would simplify to 3 and negative 1/3. But what's my last step? I always need to check these in their original. Now look, if I plugged in 3, what would I get here? I would have 3 minus 3, which gives you 0. So that solution doesn't work. My negative 1/3 will work. Alright, last one. So we need to start with factoring our denominator. Multiplies to negative 12, adds to positive 1. That's going to be 4 and negative 3. So I have x plus 4, x minus 3 in this denominator, and you put that 1 over 1. Use your brain. If we want to multiply this stuff out later anyway, this is going to have to be over here. Work smarter, not harder. I mean, if you want to work harder, that's okay. You'd get the same answer. Then over here, I need to multiply by x plus 4. Don't forget that negative that's out front. So if I copy down my work, I get x squared plus x minus 12 minus 27 equals the opposite of x plus 4. So to save some time, let's combine like terms. So minus 39 equals negative x minus 4. Once again, you want to keep your x squared happy and positive, so I'm going to move everything to the left in this problem. Just make sure you're doing the opposite. So I get x squared plus 2x minus 35 equals 0. Now, this is a 1, so I can use my shortcut here, which is what I'm going to do. What two numbers multiply to negative 35 and add to 2? That would be 7 and negative 5. So x plus 7, x minus 5 equals 0. So my two possible solutions are negative 7 and positive 5. Last step is to check, are either of those going to make my denominator equal to 0? Nope. So I'm done.